Hello and welcome back to module number 4. And today, in today's module, we are going to do quite a lot. And I hope you'll be able to catch up and be able to understand where are we going and what are we trying to achieve. So I will try to frame it in a way that it will be easier for you to understand why is it so important also to learn about statistics when it comes to the visualization aspect of that. I will also, based on my discussion, will be chapter number 5 and about the graphical communication, and in the end, which will be a next, I will present that in the next video. It will consist of Plotly. Plotly is a web browser application that allowed you to do the visualization. There is a lot of good things about Plotly and there's a lot of bad things about Plotly, and I will talk about that in the next video. So let's start with today's module and let's go over that few things that I talked about in the last module. We talked about simple principles from our textbook. And we said comparison, we're talking sorting, we're talking about filtering. All those things are part of the basic terminology in order for us to start the conversation or start to express ourselves in visual form. But before we will jump into more advanced techniques and advanced understanding, we have to go back a little bit and talk about terminology. We are talking about statistics and we are talking about what is descriptive statistics. To those who already attended my class in advanced statistics and analytics probably are familiar with that. So in this case, I will address the other side of advanced statistics, where I'm going to introduce the idea of qualitative paradigm, and you will see how we compare those two paradigms when we are trying to achieve measurements or understanding to the world. So let's start. There are 3 types of research methodology to use to measure things, humans, etc. The quantitative methods, the qualitative methods, and the mixed methods, which blend together the quantitative and qualitative methodologies. What is qualitative? I know that in the undergrad students, you usually do not talk about that, but it is the idea of focusing of making sense of interpretation of the human and phenomena. What does it really mean? We are observing, taking notes in order for us to understand how people react or how people understand each other. We saw that quite often when we have the last election. Journalists usually took 2 types of research. One is that they ask people to log on to a website to answer questions about the candidates, but on the other hand, they also invited focus groups to understand what is behind the thoughts that one candidate is better than the other by asking questions or to have a conversation. So qualitative research is about the conversation we are having in order for us to find more about human being or how human provide interpretation to things. So the idea here is that we are doing the data collection from a very small perspective. We are talking about the research, taking notes, and involve field work, involving attending or reporting on it, and based on usually personal understanding what is being discussed or what is being described. So it is more personal compared to quantitative, where we are trying to collect data from a large set of people. So The qualitative is the idea of what does it entail, asking questions and understand. Usually, in qualitative method, we're talking about cultural description. We are talking about explore living in that community in order for us to understand what's going on, examine the meaning that people give, and developing theories that will allow us to understand what is behind that. In comparison, where the analytics come into play, it is about the amounts, it's about frequency, it's about the degree, it's about the value and the intensity. It's all about the measurements, and we are trying to measure it in large quantities in order for us to understand what does it entail. So when we are writing papers, and that's what basically my job is, we are writing with a purpose, we are looking at the literature, we are raising questions, we need to show what methodology we use to analyze the data, and in the end, most importantly, is the validity and reliability of the data, which are the measurements that I took in order for me to validate what I have going to report. So the idea here is, again, how to play it around. I'm going to give you the PowerPoint presentation, so you're going to go over that closely in order for you to understand what does it entail. So again, key assumptions based on those two type of research methodologies, and I try to give you some heads up that if you are interested to go to the next level with regard to higher education and get your master's, you will probably end up have to understand those two methodologies in order for you to apply them. So again, I gave some summaries and approaches to what it is. But back to our basis. What is statistics? So the definition of many books to define the term is usually it's about collecting, analyzing, presenting, and provide interpretation to help make better decisions. This is the idea of statistics. So why do we need to analyze? Why are we doing so much fuss about the statistical procedure that we took on? So it is the idea of, first of all, curiosity. I always like to explore new things, but it's also, it gives us the idea that there is evaluation, the compliances of the evaluation, which is a very important thing when we are talking about the coming election or the next election, or do you like PowerPoint, Microsoft, or do you like IBM? Again, the idea of measurements, the idea how do we measure and what will we do with it. In statistics, we often talk about three types of statistics: descriptive, inferential, and predictive or modeling statistics. In the class that I am teaching, we are usually covering all those components where I pay close attention to inferential statistics, where we draw conclusion by taking a sample from the population, and I will talk about that in the next slides. But this is really important. In comparison, predictive analytics is about taking a model and helped us to make predictions about the future. We saw that in the last election, where a lot of scientists try to make predictions who is going to be the next senator in the House, or who is going to be the next president. By doing that, they need to show validation to their prediction. So what is descriptive statistics? Is about collecting, presenting, and ability to show some characteristics, standard calculations such as standard deviation, in order for us to understand that. Comparison, inferential statistics, we are taking a sample from the population, we are stating the hypothesis in order for us to make predictions about the entire population. So again, each one of them has different characteristics, different procedures in order for us to make it happen. But the thing that I want you to remember is that we have definitions that everyone has to understand them in order for us to have a conversation. The idea of measuring, the idea of population, and the idea of a sample. And when you're going to encounter this conversation, I want you to make sure that you understand those terms, because this is where we're going to develop our argument in order for us to make a case. So population versus a sample, and how do we did take the sample is an issue that often been debated. But when we are talking about population, we are talking about also target population. Example, nowadays they are talking about that young people often are addicted to social media. So they are targeting population of young people in order for them to measure the effect of it, which means that they are trying to understand how is young people, not the entire population, is related to social media. A sample is taking a procedure or some reference to the elements of the population in order for us to examine it and examine it closely in order for us to make a judgment. So the reason for drawing a sample, again, less time, less work, and it allowed us to produce result faster if in case not take the entire population. There is two types of probabilities, of sample probabilities. One is non-probability, and we will declare that we are taking the sample without regard to the probability that those who participate in our sample might not be representative by the entire population. In comparison, when we are talking about probability, we are talking about probability, no probability with regard to the population, which is a very important element. So I lay out for you the type of sample use and what does it entail when we are talking about samples. But we also need to remember that we also have data that we collect. Example data, we selected or we take a sample of a class. This is a data source. A data source is usually considered to have two types. Primarily, which is we are collecting the data from observation or survey, or taking people to the experiment lab that we have and testing to see the result. Secondary data source is about taking existing data and trying to make sense out of it with regard to our questions. So in this type, we're talking about the type of data. We have categorical data and we have numerical data. And when we are talking about numerical data, we're talking about discrete and continuous. And discrete is the number of children the family has, or in comparison to continuous is the weight, because today I weigh 200 pounds, but if I will start jogging and try to make sure that I'm eating well and not eating chocolate as I like to do all day, that will help me to lose weight, and maybe in a year or two I will lose weight. So weight is a continuous type of data in comparison to categorical. Categorical is the eye colors or political party. And again, it can change, but it is more settled down compared to weight. So we have level of measurements or measurement scale, where we have the lowest level of data compares to the highest level of data. Numerical data is the lowest level, Then we have ordinal data, which is a higher level. We have, example, categorical ranking in that type of data in ordinal. And then we have interval, where the difference between the measurements, but we do not have a true zero. And the highest level is that we have a true zero, and it does exist, and this is considered to be the highest level or the strongest form of measurements. So variable is a characteristics that a study that assume different values for different elements. For example, male versus female, or age, or income, or education are considered to be a variable. A data set is a collection of observation of one or more variables into it. Okay, so this is my cartoon that I like to show all the time. I've been using this cartoon for the last 20 years, and I hope that you are ready for data analysis, because we are going to take this data analysis and try to make it in visual form. So we talked about descriptive statistics, and that's the highlight of descriptive statistics. This is something that I hope that by now all of you are familiar with, from mean, median, for range, standard deviation, and the shape of the data, and what does it entail. I go over that with my PowerPoint. Again, I did that a long time ago, and so I think overall, from what I understand, most of the students understand that. I hope you do. If you do have a problem with those descriptive statistics calculation, please let me know, and I will give you additional resource about that and what you do with that regard. So, which measurement of location is the best? One of the things that I ask is, we have 5 houses in the beach, and we are trying to do a summary. What is the mean standard? What is the median? What is the mode? And what is usually the best measurements when we want to buy a house near the beach? So the mean is generally used unless extreme value exists, and this is the outliner. The median is also often used, but it's not sensitive to outliner. So again, this is something that we often do and often apply. We also looked at quartiles. Quartile is the idea of we are dividing the range of the data into 4 segments with equal number of values per segment. And by doing that, it will give us better sense what each quartile forms. This is the formula, and again, this is a basic descriptive. I also talked about in my in the descriptive in the introduction to statistics, and in the beginning of my class in advanced statistics, we talked about the measurements of the variance. And this is the idea of what is the standard deviation do, what is it so important, and how to do that. Range is part of it, the advantage and the variance and the standard deviation, all of it are part of what we are calling the idea of the standard descriptive statistics when we are using the standard deviation. So the advantage of the standard deviation that each value of the set is used to the calculation. The value far from the mean are giving extra weight because the deviation are from the mean are squared. And okay, so this is my summary, and again, I did not do a good summary, but I want to go back to our subject, and this is chapter 5, and chapter 5 talks about visual perception and graphical communication. So back to our textbook and the visual analytics. We are talking about how do we convert those ideas into a scale or visual scale in order for us to do that. He laid out some key terms in order for us to understand what does it entail. And the idea here is that we are taking descriptive data, and we are trying to come up with the idea of how do we display that. In this case, we are using bar graph example. Helmet, the type of helmet people use, and what is efficient or inefficient helmet with that regard. So what do we need to do in order for us that the categorical value will have more present or better understand to the user or the idea of it? So the idea here is that the y-axis and the x-axis are part of how do we describe those values. And this is really important, and I want you to go back to the text, open the text, and try to understand why is it so important with regard to what it represents, and why is it so important to highlight those components when we are trying to display this visualization. So is it discrete or continuous? Again, the idea here is that usually in this type, we are usually using categorical variable in order for us to display that. So again, questions that needs to be asked, questions that you need to address yourself when you are talking about the x-axis and the y-axis, and when you are doing a bar graph, this is really important. And again, I want you to have a full sense, what does it entail, why is it good to have those understanding when you are converting it to visual analytics. So this is something that we are looking how to make the bar graph look better. What does it entail? How can I make this a better way for us to communicate? I recommend you again to read for the next class is chapter 1 to 6. I will go over that one more time, but again, this is what we are going to do here. We are trying to make the bar graph look better in order for us to communicate. So, in order for me to continue, I would like to start with the idea of time series. What is time series? The idea here is that time series capture time. We are collecting data from time, we record the data based on time, and it's based on chapter 7 in our textbook. So, our visual vocabulary consists of points, lines, coordinate system, numbers, symbols, words, and colors. And again, this is part of our way to do that. And in this case, he talks about smooth versus rough. And the idea of smooth is that the data may fall into two categories, the smooth and the rough. Technically, the smooth is just another term to fit. So that is the line or the curve that fit the shape of the data which describe the overall patterns in the data. So this is the idea. And when we have outliner in the data, we have to address that in the visualization. And this is something that is a challenge for us, because how can we make the visualization more condensed and more straightforward with that regard? So we have unusual values in the data, even though the rough data or outline can be explained as unusual values. The values can fall into normal or three possible reasons: error in the data, extraordinary events, and extraordinary entities. All those are part of our reasoning. But what do we do in order for us to do that? We can apply the patterns, and the patterns is more advanced statistical analysis aimed to identify the patterns in the data. For example, whether there is a link between two variables or there is a certain groups are more likely to show certain attributes. In addition, we can address the relationship versus the differences. So we do not apply as straightforward what we have found with regard to categorical, we can make a comparison between the groups of the variables and use statistical tests for association in order for us to make our case clear when we apply the statistics. So the idea of capturing patterns in the data, and again, this is a good example, even though you probably will not be able to identify what does it entail, but it gives you some ideas percentage-wise and target sales and satisfaction of social media with regard to the sales. So using different techniques, different outline, and taking what already exists and make it more coherent is part of what we are doing that. So what is the time series? It is the idea of capturing time. Why is it important? Because to track data through time is one of the objectives and something that we often do. For example, if you're looking for a stock, Apple stock, and you're looking at not the current time, but what the value of the stock right now, but looking through the years, you will see there was high times and low times, and you as an investor need to think about that and see a visualization that will display that. So the techniques in time series is a single moving averages, central moving averages, smoothness, and universal time series models. All of it part of the time series techniques. So a single moving averages, again, we are looking at the averages as what we are trying to do and trying to capture, and this is type of visualization that we often use. When we are talking about center moving averages, we are talking about technique that get the overall idea of the trends in the data set. And if it is the average of any subset of numbers, the moving average is extremely useful for forecasting long-term trends. And again, one of the things that is really powerful about exponential smoothing technique is the idea of trying to capture what will happen in the future and address that in a way that allowed us to use the data with regard to the mean and how it play out. And again, another model is, I'm going to leave you to read about that and to talk about it, because this is chapter 7 in our textbook. And again, this is something that is really interesting, and it is all about that. So 6 basic design patterns in time series. All of that are part of the textbook recommendation. And the idea here is that the trends is the overall tendency of the circle of the value to increase or decrease, and with regard to related to time. For example, it is common to refer to close sales during 12 months. So we can see the observation, we can see what it is entail and how it apply that. Another way is to measure the ability of averages of change, and this is also very important. Low averages, high averages, or medium averages, and how to do that. So using the visualization can make a stronger case to see or detect those averages, how they change. The rate of change is, again, from one variable to the next, can have an effect how you're going to display that in the visualization. Next level of the rate of change, again, think about that in the sense of water. After 10 minutes, after 20 minutes, and after 30 minutes, and you will see that the level of water has grown. And so this is the rate of change. Covariance, again, is part of how we apply that and how to think about that in that sense. A circle is another way to show or to reveal patterns in the data based on a daily or weekly or monthly or quarterly or yearly. And again, this is how to do that. When you are concerned about explanations and a reveal about that, you usually think about data that analyze and some patterns of change through the time that are particular interest to you. So we usually apply the time series in line graph, bar graph, dot graph, radar graph, and heat maps. Those are the common platform to display time series. So the line graph, again, this is temperature in New York, and this is something that we often use. Radar graph is a little bit more complex. We are able to display the time through, as you can see here, and show the average temperature and high and low, and be able to do that with regard to the scale that we have. And heat map, again, this is sometimes people complain about heat map, that it is not really understood and with regard to comparison. But again, this is part of the vocabulary that you will need to be familiar with when you are talking about time series. How can you convert heat maps into time series? One of the things that is really important, and that's why I like this book so much, is that he in the end of every chapters, he give us best practices in time series. And he lay out for us what does it entail. I want you to go over them, to think about them, and to understand why is it so important to understand that with that regard. I will not, because it's this class is going to be a little bit longer than before, I'm going to give it to you as it is. I want you to think about that, and you're going to analyze based on the best practices. You're going to pick up example of a time series and see how it is applied to best practices. So again, daily versus monthly, viewing of the viewing time periods in context, grouping related time interval, using averages to enhance understanding in the data, or obtaining missing value from a display, optimizing the graph aspect of ration, and using scale to compare the rates of change. And this is something this is really important. Overlapping time scale, I went over all those components, I display them, so you will be able to see that, be able to understand that, and be able to apply that. You will pick one element and examine the visual that you found about time series and try to analyze it. Is it matched to that components? So again, I recommend that when we design time series, it's important to apply that and trying to understand what does it entail. I know that I jump into all those components. It's a lot of information. I know that this is a very intense module, but I hope that you'll be able to break it down, to take those PowerPoint presentation and go over them and to understand what does it entail and to understand our textbook with regard to the best practices in time series. So until next time, and the next video will be about Plotly, and I hope you enjoyed it, and please let me know if you have any other questions.